So let's do the exercise 13.1 in probability. It's called conditional probability. P of E is given as 0.6. P of F is 0.3. P of E intersection F is 0.2. They're asking for P of E by F. The occurrence of E under the condition that F has already occurred. Under the condition F has already occurred, what is the condition that E is occurring? So the formula for this is P of E intersection F by P of F. You know, E intersection F is 0.2, P of F is 0.3. So therefore it's 2 by 3. So next is they are asking P of F by E. In that case is P of F intersection E by P of E. It doesn't matter, E intersection F and F intersection E are the same. So it's 0.2 by P of E is 0.6. So it's 2 by 6 or a 1 by 3. So let's go to next sum. That completes the first question. The second question, compute P of A by B. What is the formula? P of A intersection B by P of B. Okay, where? Oh, everything has been given. P of A intersection B is 0.32, P of B is 0.5. So multiplying the numerator and denominator by 10, it's 3.2 by 5 or a 32 by 50. And you can write it as, what to say, it's 32 by 5 into 10. Let's keep it like that. And let's cancel it off with the two tables. This will become 16, or you could have even cancelled it as it is. This will become 16, this will become 25. So 16 by 25. So let's go to the next question. The third question, P of A is 0.8, P of B is 0.5, P of B by A itself has been given as 0.4. The formula for this is P of B intersection A by P of A itself is 0.4. You know what is P of A? So P of B intersection A by 0.8 is equal to 0.4. So P of A intersection B and B intersection A are the same. 8 4s are 32, 0.32. So thus you got A intersection B from this. What are they asking next? Find, P of A intersection B. Then the question is P of A by B, which is P of A intersection B by P of B. A intersection B is what you found, which is 0.32. By P of B is 0.5, which is nothing but 32 by 50. Okay, so let's go to next. You can always cancel this, 16 by 25. And P of A union B. What is the formula? You should know from last year's portions. P of A plus P of B minus P of A intersection B. So P of A has been given to be 0.8. P of B is 0.5. A intersection B is 0.32. That will give you P of A union B. Just add this, you'll get 1.3 minus 0.32. And 1.3 minus 0.32 is, let's put a 0 here, there will be 10. This will become 2, 12. 12 minus 3 is 9 and 0.91. So let's select this. Let's go to next question. The fourth question, P of A union B is what? You know the formula. P of A union B is P of A plus P of B minus P of A intersection B. What has been given in this question is 2 times P of A is equal to P of B is equal to 5 by 13, which shows that P of B is 5 by 13. P of A is 5 by 26. So P of A therefore is 5 by 26 and P of B is 5 by 13 itself. And what else they have asked? They have given P of A by B. P of A by B is 2 by 5. What is the formula? P of A intersection B by P of B is equal to 2 by 5. A intersection B, you can therefore find out from this. What is P of B? P of B is 5 by 13. P of A intersection B by 5 by 13 is equal to 2 by 5. P of A intersection B is therefore 2 by 5 into 5 by 13. So the answer is 2 by 13. So that's what is P of A intersection B. But they are asking for P of A union B. You know P of A is 5 by 26. P of B is 5 by 13. P of A intersection B is 2 by 13. So the LCM will be 26. So it will be 5 plus 5 2s are 10 minus 2 2s are 4. 10 minus 4 is 6. 6 plus 5 is 11 by 26. So something you can check your book back answers when you're doing. If I've made a calculation mistake, I'm not sure about that. So let's see, E is a head on third toss. Head on third toss means the third toss has to be head. Okay, whatever it is, the third toss. So I can have third toss has to be head. Head on the third toss, and F means head on the first two tosses. Heads on the first two, H and then blank. Like you know that head on the first two tosses means it doesn't say heads on the first two tosses only. It doesn't say that. So I can, in my own way, I can predict it as H also can come. T also can come, because according to me they didn't specify the heads on the first two tosses only. So heads on the first two tosses means third also can be head, is what I am assuming. I don't know. I'm just assuming like that. E is head on the third toss. Head on the third toss means it can be also head on the first two tosses. That's the biggest doubt I have. Since they didn't specify only, it means you can keep it like that. We can check the answer. We can heads on the first two tosses means can also be H and HHT. And here last toss is head, which means you can have a HHH. Then HTH and THH. And you can also have a TTH. You agree with me?
Yeah.
Is there anything more? I think that's it, right?
Yeah.
So these are what it is. So you found what is E and what is F, and you've listed it. Okay, and do you know the sample space? The sample space of a 3 coin which is tossed will be how many number of outcomes are there? 2. To the power how many times you are throwing? 3 times. So it's 2 to the 4, 4 to the 8. Sample space will have 8 of this. Just to know it, because every probability is out of the sample space. Now the question is, what is it? They are asking you to find P of E by F. The probability of E occurring under the condition F has already occurred, which is P of E intersection F by P of F. Just see what is intersecting between E and F. Can you see that only this one, which is only 1 out of a sample space of 8 by P of F. How many P of F is there? 2 out of sample space of 8. So the answer is 1 by 2. Do you get that?
Yeah.
So like this you have to understand the question listed. This completes the first question. Let's go to the second question. The second question is E is at least 2 heads. At least 2 head means 2 heads or 3 head. So I can have HHT or HHH also. At least 2 heads means, correct? But I have to juggle this. So it can be HTH or THH and then HHH. So this completes at least 2 heads, which is 2 heads and 3 heads, which is E. Let's go to F. What is F? At most 2 heads. At most means 0 head also will come. 0 head, which means TTT. Then 1 head, which is HTT, and you have to juggle it, THT and TTH. Then at most 2 heads means 2 heads also must include. So HHT, and you have to juggle it. So HHT means HTH and THH. That's all. This is at most 2, which means 0 head, 1 head and 2 head. At most means 0 also must be included. So then that's what it is. The condition probability of P of E and the condition that F has already occurred is P of E intersection F by P of F. What is intersection between E and F? Just underline. You have a THH, which is here, a THH is here, and 3 heads will not come. Obviously it will not be. HTH will be there, HTH will be there, HHT will also be there, HHT will also be there, obviously. So what is intersecting? How many are intersecting? 3 are intersecting out of sample space of again 8. 3 out of 8 is intersecting by total of F. 1, 2, 3, 4, 5, 6, 7. 7 out of 8. So the answer is 3 by 7. If you don't write the sample space below, they won't give you marks. So you must be very careful. Let's go to third question. E is equal to at most 2 tails. At most. I told you at most means 0 tail. 0 tail.
So it's HHH.
Yeah, which is HHH. 1 tail or 2 tail. THH and juggle it. HTH and HT and also 2 tails, no?
So
2 TTH and juggle it. THT and TTH. No, that I've written. Okay, HTT. Yeah?
HTT, yeah.
That's it. That's E. Let's go for F. At least one tail. At least one tail means one tail, two tail or three tail. Oh, so one tail with two H and you have to juggle it. So you know it's a H T H or H H T. Then two tail with a head, which will be T H. Okay, T H T. Next is H T T. And also you have to include the other one, which is T T T. Because at least one tail means one tail, two tail or three tail. Done. So the question is P of E by F. What is intersecting P of E intersection F by P of F? Sometimes I'll ask you F intersection F by E also. You should be very careful. What is intersecting? Underline what is intersecting. THH, HHT, juggled, right? HTH, HHT,
then
TTH,
Oh,
THT,
everything is intersecting.
HTT, except for HHH because it's HHH and TTT. So then how many is have we underlined? 1, 2, 3, 4, 5, 6. 6 out of subspace of 8 by what is in F? 1, 2, 3, 4, 5, 6, 7. 7 out of 8, the answer is 6 by 7. So do you understood? I hope. Let's go to the next question. So 7th question. I'm recording, right? I hope I'm recording.
I think you are. Yeah,
22.
you are.
Okay. The two coins are tossed once. Okay, what is E? Two coins are tossed only once. Okay. Tail appears on one coin. On one coin. It doesn't say exactly one coin, right? Tail appears on one coin. Can it mean it appears on one coin or two coin? Can you check that? According to me, it can appear on one as well as two. Because this one coin. I don't know. I don't know what is HT and TH. Should I write a TT? Is my question. That is the question number 7. So it's correct. So when they say tail appears once, tail appears once only, they have not given. The tail appears on one coin. So then this TT also, tail is appearing on one coin. So you have to include that. That is something you need to remember. F is equal to one coin shows head. One coin shows head. Exactly one coin shows head. That's what I am understanding. Exactly one, just it HT and TH. One coin shows head.
One coin shows head.
HT and TH, see?
Yeah.
So the meaning, how am I inferring? One coin shows head, na compulsorily only one coin shows head. But tail appears on one coin means, it can appear in one coin or two coins, still it will have, that is the trick you should understand. Once you understand that, it's over. Okay, but when they say, one coin shows head, it's very rigid. One coin shows head. I don't know. That's how I think. So P of E intersection P of E by F is therefore P of E intersection F by P of F. And what is intersection with HT and a TH, which is 2 out of a sample space of what is a sample space? There are 2 outcomes and you're throwing it
Once.
head and tail. You're throwing it twice, right?
Once,
No. 2 coins are tossed. Okay, so then when you toss 2 coins and for 1 coin the total outcome is 2. For 2 times means 2 to the power 2, so it will be 4 outcomes. So 2 by 4 by P of F is 2 by 4. What? So the answer is 1. Is the answer 1? Outcomes to the power number of times you're throwing. Yeah, so that completes it. So let's go to next sum, which is the 5th question. 5th question, a die is thrown 3 times. The total outcome will be 216 times. You know, the total outcome of 1 is 6 to the power 3. So the total sample space will be 216. 4 appears on the 3rd toss. 4 appears on the 3rd toss means 4 can appear on the first 2 also. It appears on the 3rd toss. So it can be 1, 1, 4. Correct? 1, 2, 4. 1, 3, 4. Yeah? 1, 4, 4. 1, 5, 4. 1, 6, 4. Then I can start with 2, 1, 4. 2, 2, 4. 2, 3, 4. 2, 4, 4. 2, 5, 4, 2, 6, 4. Then I can start with 3, 1, 4, 3, 2, 4, 3, 3, 4, 3, 4, 4, 3, 5, 4, 3, 6, 4. 4, 1, 4, 4, 2, 4, 4, 3, 4, 4, 4, 4, 4, 5, 4, 4, 6, 4. 5, 1, 4, dot, 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 6, 1, 4, 6, 6, 4. All this is where I am getting E. Next, let's go to F. 6 and 5 appears respectively on the first two tosses. F is 6 and 5. So it will be 6, 5, 1, 6, 5, 2, 6, 5, 3, 6, 5, 4, 6, 5, 5, 6, 5, 6. And what will be intersecting is only this. Because in all this, you know, the last digit is 4. So you need not have written everything. You know, 1 only will be intersecting. So 1 out of 216 by 1, 2, 3, 4, 5, 6 out of 216. Therefore, 1 by 6 will be P of E by F. You don't have to list it. When you read this, you really understand. So let's go to next question, which is the 9th question. Mother, father, son. Line up random order. First, mother, father, son. You know, you can juggle it as 3 factorial ways, which is 3 2s are 6 ways. So sample space is 6. So now mother E is event E, son on one end, which means son can be here and a mother father can be here. Son on this end, father mother can be here. 2 arrangement. Son can also be on the extreme with mother father and father mother. Correct? These are the son in the extreme position. Then F. Father in the middle. Place the father in the middle, son and mother, or mother and son. So P of E by F is P of E intersection F by P of F. What is intersecting between them? Son and the extreme end will, both of them will intersect. Son, father, mother, and mother, father, son. So 2 out of sample space of 6 by a 2 by 6, which is just 1. So let's go to 10th question. A black and a red die are rolled. Black die and a red die are rolled. Find the conditional probability of obtaining a sum greater than 9. Sum greater than 9. Which means the sum can be 10, 11 and 12. Only 3 possibilities. Correct? 9 cannot be included. Greater than 9 means not include 9. Or greater than or equal to only we should include. Given means F. The question is E and given is always F. What is find the conditional probability. Find is E. The probability of obtaining a sum greater than 9. Let's list what is E. Is sum greater than 9. Sum is, it has to be 10 means it can be 5 and a 5. Then it can be 6 and a 5.
Greater than 10, okay.
No, 4 and 6 can come. What you said is right. Because it can be 4 and 6, 6 and 4, 5 and 5, correct? Then it can also be, we finish
Yeah.
this 10. Then we have to go for 7 and 3 also will not come because it's a die.
It's a die, right?
So then that's all. So 11. 11 will come in
5 and 6.
5 and 6,
6 and 5.
6 and 5. That's all. 11 cannot come in anything else.
Yeah.
Yeah, because 6 is maximum. If I put 5 and 5, it gets to 10 only. So next is 12. Can come in 6 and 6. That's the only case where it gets. So sum can be 10, 11 and 12 and I've listed E. What will be F? What is the condition? Given that the black die resulted in a 5. The black die resulted in a
5.
black die resulted in a 5. Find the conditional probability of obtaining a sum greater than 9 given that the black die resulted in a 5. Oh, the black die always resulted only in a 5. So definitely a black die and red die are rolled. 5 black and red can be 1. A 5, a 2. Correct? Black, red. A 5, 3, a 5, 4, a 5, 5. You agree with me?
Yeah.
A 5, 6. Because the black die has to necessarily end up getting 5. So then the red can be 1, 2, 3, 4 till 6. Here we didn't list it. Let's list it as this is black and this is red. Correct?
Yeah.
And we also switched it wherever required, right? 5, 6, 6, 5. Yeah. So this is what it is. And so then this is black, this is red, black, red, black, red, black, red, black, red, and P of E intersection F. Okay, let's see, find the conditional probability of obtaining some, given that the black die resulted in a 5. So P of N by P of F. What is intersecting these two? Okay, that in this is 5, 5,
5,
5, 6.
So 2.
Black, red in that order,
Yeah.
right? Nothing else?
No.
So it's 2 out of, as usual, there will be 36 outcomes by 1, 2, 3, 4, 5, 6 out of 36. So it's 2 by 6 or 1 by 3. So let's go to next question. It's the sum number B. Find the conditional probability of obtaining the sum 8. Okay, find is always E. Given is always F.
Given the
Sum is always 8. Let's list that. Sum is always 8 means it can be 2, 6 and 6, 2. It can be 3, 5 and 5, 3 and a 4, 4. That's all, correct?
Yeah.
Given that the red die resulted in number less than 4. Red die less than 4 means, let's consider that this is second one is a red die. And less than 4 means it can be 1. And with 1 you can write 1, 1. Correct? 1, 2, 1, 3.
1.
No. The red die has to be,
Yeah, less than 4.
it has to be 2, 2, 1, 3, 1, 4, 1, 5, 1, 6, 1. And then it has to be 2 next.
2, 1.
So it's 1, 2.
Oh, 1, 2.
Then it can be 2, 2, 3, 2, 4, 2, 5, 2, 6, 2. Then it can also be 1, 3, 2, 3, 3, 3, 4, 3, 5, 3, 6, 3. Less than 4 only, no?
Less than 4, yeah.
So then that's all. 1, 2, 3 can come. I've listed it. So what is common between them? You have this is always, what is the condition? I forgot the condition. Resulted in a number less than
Less than
4. Yeah, the second number is less than 4, right? Look for a second number less than 4. There's a 5, 3 here, which will definitely intersect. Yeah, there will be a 6, 2, which will definitely intersect.
Yeah.
But you have to look for the second number which is less than 4. Here you have a less than 4, less than 4. So then 2 out of 36. P of E intersection F by P of F will be 2 out of 36 by F, which is 1, 2, 3, 4, 5, 6. 6 3s are 18 by 36. So it's 2 by 18 or a 1 by 9. Correct?
Yeah.
Next. I have to go to 11th question. Correct? A fair die is rolled where E is equal to 1, 3 and what are they listed? 1, 3 and 5.
5.
F is equal to 2, 3. G is equal to 2, 3, 4, 5. One die only.
Yeah.
Okay, now P of E by F is P of E intersection F by P of F. What is intersection between E and F is just 3. Only 1 is intersecting.
Yeah.
Out of sample space of 6 because once only you are throwing, correct?
Yeah.
By F, F is 2 by 6. So therefore 1 by 2. Next, what did they asked? They asked P of F by E, which is again P of E intersection F and F intersection E is same, but P of E, which is 1 by 6 by what is E is 3 by 6. So 1 by 3. So let's go to next sum, which is P of E union F by G. Third one.
Yeah.
P of E union F by G is P of, this is the conditional property is G. So you write P union F intersection G. This intersection that by P of G. So what is union? Let's write E union F. P of, first write E union F is 1, 2, 3, 5. Okay, by P of G. That has to intersect with G. Just look for intersection with G. 2 and 3, 2, 3, 5. 2, 3 and 5, which is 3 are intersecting. 3 are intersecting. By P of G itself is how much? 1, 2, 3, 4. So that's what it is if they ask you something complex.
E by G.
P of E by G is P of E intersection G by P of G. What is E intersection G? E intersection G is just 2 and 3. So you have 2 by P of G is 4. So therefore it's 1 by 2. Let's go to next. What is it? P of E union F by G. You know what it is? It's this by this. So this is P of E union F intersection G by P of G. And you know E union F is what? It's this 1, 2, 3, 4. Intersection with G was just 2, 3 and 5, which is 3 by P of G, 4. So therefore it is 3 by 4. Did we do something? Yeah.
G by E.
Huh? Isn't this same as this?
This is intersection E intersection F.
Oh, this is This is union. Union means it's not. You have to write everything.
No, in the question it's E intersection F. First one was E union F by G. This one is P of E.
Oh, what we did was union.
Yeah.
1, 2, 3, 5. But this is in the intersection.
We did union twice. We did P of.
No, let's go in an order. What was the first question?
This one. P of
E by F. Then P of F by E. Next is P of E by G. Here,
E by G.
P of G by E.
didn't do.
Okay, but you can do that. You
Yeah.
know how to do it. Next is P of
E
E union F by G is what I've done here.
Yeah.
Next
We've
is
done it here as well.
P of E union F by G.
We didn't do. This is E intersection F. You didn't do
Yeah.
E intersection F.
Then I did P of E by G here. Whatever is left out you told me to do, I seem to have done it here. Next is P of, oh, this is wrong.
Yeah. We are supposed to do E intersection F by G.
P of E intersection F
By G.
by G, which is P of E intersection F intersection G by P of G. Correct? E intersection F is what? E intersection F is just 3.
1.
It's just 3. Intersecting with G will also be 1. Out of P of G is 4. So just write that. Let's go to the next question. 12th question. Assuming that each born child is equally likely to occur, boy and girl, if a family has 2 children, what is the conditional probability that both are girls? What is always E. Both are girls means GG.
G.
Okay, E given that the youngest is a girl. So it can be boy, girl. Youngest has to be girl. Can also be girl, girl. So what is intersection? P of E intersection
Girl. 1.
F by P of F will be only 1 is intersecting out of sample space of 4 by 2 by 4. So then therefore it's 1 by 2. Next. Youngest, at least 1 is a girl. So which is what is the probability? What is the condition probability? Both are girls stands the same. Given that only changes, which means F only is changing for the second case. Whereas at least 1 is a girl means girl, boy, boy, girl, girl, girl. So F is changing. The E remains the same. So intersecting is 1 by 3. So P of E intersection F by P of F in the second case. Let's go to next question, which is the 13th question. An instructor has a question bank consisting of 300 easy true or false. So there is an easy true or false question, which is 300. 200 difficult true or false question.
And 500 easy.
500
MCQ.
easy
MCQ.
multiple choice question.
And then 400.
400 difficult. Yeah.
What is the probability that it will be an easy question given that it is a multiple choice question?
What is the probability is always called E. Easy question. Given that it is a multiple choice question. This means only MCQ. This means only easy. What are the easy questions here? It's totally 300 true or false and 500 MCQs are easy. Let's write F, which is only MCQ, which is 500 easy and 400 difficult. Okay, so now look for the question. Given that if the question is selected random from the question bank, what is the probability that it will be an easy question? So E is easy question given that multiple choice. So what is intersecting? P of E intersection F by P of, what is intersecting? Is an easy 500
Yeah, 500 easy
MCQs. Yeah.
So 1.
So this is what it is intersecting. So it's 500 is intersecting, not say 1. 500 is intersecting. By F is 500 plus 400, 900. So therefore it's 5 by 9. Okay, if you want the total probability, you have to add all these questions.
Okay.
So in by 800, 1000, 1400, this by 1400, by this by 1400. Anyway, that's going to get cancelled, but you should write the sample space. Let's go to next question. 14th. Given that the two numbers appearing on throwing two dice are different. So it's not doublet. Doublet means 1, 1, 2, 2, 3, 3, 4, 4, 5, 5. It's non-doublets. So it will be there are 6 doublets. So 36 outcomes, 6 doublets goes away. It will be 30 outcomes will be there. So keep it like that. That is what is your E. What is it? Two numbers appearing on the die are different. The probability of the event, the sum of the number on the die is 4. Given is this. So which means F is given. They are going to be different. And E is the sum of the number in the die is 4. What are those listed? 1, 3, 3, 1 and then 2, 2. Okay, here they are saying F is completely different. So this will not be there. It will not be intersecting with F. You may have 1 and 3 and 3 and 1 which is going to be intersecting with this. So then there are P of E intersection F by P of F will have two things which are intersecting. Out of what is F? F itself has got 30, so 1 by 50. I want to know the answer for this sum. Just check now, 14th one. Yeah, so that it's 15, sorry. So 1 by 15. We are doing correctly. Okay, so far so good. Let's go to next question. Consider the experiment of throwing a die. If a multiple of 3 comes up, throw the die again. So you might get a die 3, 1, 3, 2, 3, 3, 3, 4, 3, 5, 3, 6 because you are throwing a die again. Multiple of 3 means not only 3, it can also be 6. 6, 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, 6. Okay. If any other number comes, toss a coin, which means if 1 comes, 1H, 1T, 2H, 2T, 4H, 4T, 5H, 5T. Correct? Other than that. Okay, find the conditional probability event, the coin shows a head. So question is about the coin showing a head. Where all coin is showing head? 1H, 2H, 4H, 5H. That's all. Okay, under the condition that
at least one die shows a 3.
At least one die shows a, no, what is it? Find the conditional probability that the coin shows a tail, Kanna.
Oh, not the
Head. So it's 1T, 2T, 4T, 5T. Correct?
Yeah.
And what is F? At least one die shows a 3. What are those which, so you have a 3, 1, 3, 2, 3, 3, 3, 4, 3, 5, 3, 6, 6, 3. And here you don't have. So which means nothing is going to be intersecting. So then P of E intersection F in this case is 0. Therefore by P of F will also be 0. So let's go to next question. 16th question. P of A is equal to 1 by 2. P of B is equal to 0. P of A by B is what? P of A intersection B by P of B. And you know P of A intersection B. P of B itself is 0. So undefined is the answer. So let's go to next question. 17th question. If A is a subset of B, okay, they have already given P of A by B is equal to P of B by A. What is the meaning of that? P of A intersection B by P of B is equal to P of B intersection A by P of A. Since these are equal, this will also be equal. So P of A will be always equal to P of B, right? Now that's the answer. So D is the option. Okay, so the complete exercise is recorded. But having said that, the most important part, if this sum, as soon as you see, what should strike you is the crow, inner probability. But we didn't have to see it because nothing was intersecting. But this you have to identify to be the crow sum because you have to look at the inner probability. Similarly, this example 7, the example 7 in the textbook is the world's most important sum, where they are saying find the conditional probability event that the die shows a number greater than 4 given that at least one. So E is the die shows number greater than 4. Consider the experiment tossing a coin. If the coin shows head, toss it again. So head na you're tossing coin again, HH and HT. If it shows a tail, throw a die. So it will be tail 1, tail 2, T3, T4, T5, T6. This is what is happening. And what is E? Find the conditional probability of the event that the die shows a number greater than 4. So where all it's greater than 4? T5 and T6. What about F? Given that there is at least one tail, list everything, T1, T2, T3, T4, T5, T6 and HT. You should not miss HT. So what is intersecting is T5 and T6. So you can't write 2 is intersecting out of 1, 2, 3, 4, 5, 6, 7. It will be wrong. So you have to look at inner probabilities, correct? So what is intersecting is T5 and T6. Let's look at this probability, inner probability. 1 by 2 into getting a 5 is 1 by 6 plus tail is 1 by 2 into 1 by 6. This is what has to be on the P of E intersection F is what is this 1 by 12 plus 1 by 12 which will be 2 by 12, correct? By P of F. Probability of F, again you have to look at inner probability. What is the inner probability of T? 1 by 2 into this is 1 by 6. This is also 1 by 2 into 1 by 6. 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 But HT is 1 by 2 into 1 by 2. H and T. So this is coming 1, 2, 3, 4, 5, 6 times. Which one? 1 by 2 which is 1 to 1 by 6 is 1 by 12, right?
Yeah, 1 by 2.
1 by 12 is occurring how many times? 6 times. Plus 1 by 2 into 1 by 2 for the last one head and tail is just 1 by 4. So you have to this is 2 by 12 plus 6 by 12 plus 1 by 4. Let's take LCM down. 12 is LCM into 3. 9 by 12. 12 and 12 gets cancelled. 2 by 9. Which is not the same as what you thought because we got 2 by 9, 7 or something. So you have to look at inner probability. That's what makes the sum very, very important. Then of course you can try out all the other example sums which are pretty easy. And I'll just teach you something that I'm sure that's it. That's it. I'm done with this. There's nothing much. Okay, that's about it, guys. So just make sure you're practicing everything and becoming thorough. I'll record the 13.2 in another video, so that's done.